Are we on? Is this? Oh, I'm sorry. So, yes, physics. It involves free fall. So we're going to talk about free fall today, and so we are going to be doing something with free fall. And since it's free fall, I'll be working without a net. That's right. So all of the things I'm going to write here could be horribly, horribly wrong, but we're going to go through it anyways and see where it takes us. So here's our problem. Small child, let's call him Tyler. I don't know why, maybe it's my son or something. Throws something into the air with an initial velocity of 5 meters per second. If Tyler is standing on top of a table that is 1.5 meters high, how fast will the object be traveling when it hits the ground? So let's draw a table. It's a good table. All right. Now we're going to assume the ball here is thrown upwards. Pay no attention to outside noises. Upwards at 5 meters per second. And it was thrown, the table was 1.5 meters high. So I'm going to call this 1.5 meters. And that means I'm going to call this 0 for the ground. I could have chosen some different options, but that's what I'm going to go with. Let's see what it takes me. Now, I like to list my givens. Okay, so let's see. I know my initial velocity is 5. All right. And I know my displacement is equal to, well, my displacement is always final minus initial. So my final is 0, my initial is 1.5. So my displacement is negative 1.5 meters. Let's put meters per second on this bad boy. And we want to know how fast we'll be traveling. So that's a velocity. Oh no, it's unsolvable. Wait, we're in free fall. So we know the acceleration of the object, since in free fall, is negative 9.8 meters per second squared. That's right, that's all it is. So, if I go to solve this problem, I just say, well, what am I given and how can I go about solving this? Well, the equation that then helps us out is v final squared equals v initial squared plus 2a times our displacement. So now it's a matter of just bringing things in where they belong. I don't know what that velocity is. My initial velocity is 5. Square it. 2 times negative 9.8, and then my displacement is negative 1.5. Solve for v, and you get, I use my computer, and survey says we get 7.3, let's go with 8, I'll call it an 8 meters per second. That's what my calculator told me. But if I listen to my calculator, this means the object is traveling up. And that would be awkward if you threw stuff up and they still went up. So I have to use my brain and say, well, velocity has direction built into it. And so it's got to be a negative, because whenever you take the square root of a number, it's plus or minus. So that's telling me that my velocity is a negative 7.38. Now, that's just how fast it's going when it hits the ground. I could have asked other questions. Like I could have asked, what is the max height? Well, if I asked the max height, then I had to bring in some extra information. So, for example, I know my initial velocity would be still the same at 5. I know my acceleration is still the same at negative 9.8. I do not know what my displacement is. I don't. But I do know that my final velocity is 0, because when an object reaches its max height, it comes to a stop. Because if I drew a position time graph for this guy, he would have gone up and down, and right here, the slope of that line is 0. So therefore we have to have a velocity of 0 at that peak. All right? So now if I want to say what's my max height, I could have then said, well, let's see, what's my displacement? Equals unknown, and oh look, it's the same equation. This is a popular equation we're having today. So v squared equals v sub naught squared plus 2a times my displacement. I then now know 0 equals 5 squared plus 2 times negative 9.8 times my displacement. And then I have to solve for that displacement. Let's go to the computer. All right, back from the physics computer. And the physics computer says that the displacement is 1.2, and I'm going to call that 8, because it's 755 meters. But that's not my answer. That's not my answer, because in my drawing, I want to know what's the max height. That's just from here. So I'm going to have to add the 1.5 to that to figure out what the actual answer is. So the max height is equal to my original displacement of 1.28 plus where the object was at 1.5 meters. So my max height is actually 2.78 meters above the ground. All right, so these are two types of problems you might be asked when solving this, and that's basic free fall stuff. So different types of problems. We just happen to use the same equation twice in a row, but you could use any of your kinematics equations to solve these that have acceleration in them. And I hope that helps. Have fun.